Hey guys, so here's the notes for 5.4 day 1. We're going to be talking about factoring about polynomials. Now, when we are factoring, the first thing you should do is see if there's a common factor. This is what we call the greatest common factor. This could be a number, a variable, or both. After that, check to see what is left if it can be factored anymore. Okay, let's look at number 1. We have c cubed plus 9c squared plus 18c. Let's see if these three terms have anything in common we can take out. They do have a variable in common, and the most that we can take out is just a c. Okay, now when we rewrite, we got to take that c out. So we're going to take a c out of a c cubed, I'm going to c squared. Then the plus 9c squared becomes plus 9c, and I'm left with plus 18. Now, inside the parentheses, we have a quadratic. Now, we've done already factoring quadratics. And our a value, so the number in front of the c squared, is a 1. So all we need to do is decide what are numbers that multiply to 18. Those are what we call the factors. We have 1 and 18, 2 and 9, 3 and 6. Let's see, are there any pairs that add up to our middle term of the positive 9? Yeah, 3 and 6. Okay, so that c that we have in front, make sure you bring that down. If you don't and you multiply back, you're not going to get the original problem. Okay, we do two sets of parentheses. We have c and c, and then we know 3 and 6. To get a positive 9, both of them need to be positive. And notice that all of our terms are linear, meaning all of the variables are to the power of 1. That's when we definitely know we are done and we can't factor anymore. Okay, let's look at example 2. We have 3y to the 5th minus 48y cubed. Let's see if they have anything in common. They do. They have a 3. And the most that we can take out for our variable is y cubed. So with the numbers, we divide. 3 divided by 3 is just 1. And then when we take y cubed out of a y fifth, we're left with y squared. Negative 48 divided by 3 gives us negative 16. And no more variable. Now notice, this is something that we have also factored in quadratics. This is what we call our difference of squares. Okay. So remember with the difference of squares, that means we have a binomial. That means two terms. Our a and c values are perfect squares. So the number in front of y squared is 1. 1 is a perfect square, and 16 is a perfect square. And we're subtracting the two terms. That also means difference. So when we are factoring this, first of all, make sure you bring down that 3y cubed. When we factor this, we have two sets of parentheses. 1 is a perfect square. The square root of it is just 1. So we're just left with y's. Now the square root of 16, remember that's what you do, is 4. And we have one positive, one negative. Notice what's inside the parentheses, the y plus 4 and y minus 4. They are linear expressions. We're done. Now the 3y cubed, though that's not a linear, that is a monomial. And we can't really factor monomials. So we're basically done here. Okay, let's go ahead and do our next one. So this is where we're going to be talking about factor by grouping. Okay. So what we're going to do is whenever you have basically a polynomial that is to the third power and you have 4 terms, you're going to want to factor by grouping. Now, you should always ask yourself if the terms have anything in common that we can take out. So we look at y cubed, negative 7y squared, 4y, negative 28. Well, they don't have any numbers in common other than 1, and not all of them have a variable, so we can't take that out. So there's no greatest common factor. So now we result into the idea of factor by grouping. So what we're going to do is we're going to take the first 2 terms and group them with a parentheses, and then the next one we're going to group as well, the second set, or the second 2 terms there, okay? Now, when we group, we are going to determine what do those 2 terms have in common that we can take out. So let's look at y cubed minus 7y squared. What do they have? This is what we call our greatest common factor that we can take out. That's going to be a y squared. Now, we do need to rewrite what's in that set of parentheses, so we have y minus 7. Now, we do have a plus. And notice that I did not put it inside the parentheses. You can if you want to, you just don't have to. We know we will have to add with that operation there. Now 4y minus 28, we group that. Let's figure out what do those 2 have in common. Well, those 2 have a 4. So I'm going to take a 4 out. Now we just divide the numbers. So 4y divided by 4 gives me y. and negative 28 divided by 4 gives me negative 7. So now notice here that our y minus 7s are exactly the same. That should be what happens, okay? So you should always get the same factor that is inside the parentheses. If not, you need to rethink of how you did it, okay? Now, we're going to place these things together. So my y squared and my plus 4, I'm going to put that in a set of parentheses. And then my y minus 7, that's going to be in a parentheses. Now, some of you might be wondering, well, why are we not putting y minus 7 squared? Well, the reason being is, notice, if we have y squared, that's going to be multiplied to the y in negative 7. If we rewrite it like two factors, you're doing the same thing, taking y squared and distributing to the y in the minus 7. That's going to be the same thing with the 4. You're only taking 4 and multiplying by the y in negative 7. Same thing if we are have two of these sets of parentheses, you're taking the 4 and distributing to the y in negative 7. So just think of these two here, two different ways of writing the same idea, okay? So these are just two different ways of how we can write it. Okay, now from here, we want to see, can we factor any more? So the y squared plus 4. Now, this is a binomial. Our a and c values are perfect squares, but notice this is a plus instead of a minus. So this is not a difference of squares. And we really can't factor this anymore. What about the y minus 7? Well, that is a linear expression, and once again, we can't factor that, okay? So basically, our final factorization here is y squared plus 4, y minus 7. Okay, let's go ahead and do example 4. What I would like you to do is go ahead and pause the video and try this one on your own. Okay, let's see what you got here. So once again, make sure you group. So we group the first two set of parentheses, and then we're going to group the second set of parentheses. Okay. Now remember, before doing that, okay, make sure you look at all 4 terms. And actually, let me erase this. Let's look at all 4 terms. Do they have anything in common? Well, actually, no. The only number they have in common is a 1, and they don't all have variables, so we can't do it. Now notice this is where we have 8 cubed and we have 4 terms. So this is where we're going to factor by grouping. Okay? So anytime you have to the third, that's your largest exponent, and 4 terms, you're always going to factor by grouping. Okay, so now let's look at what is the greatest common factor between the first 2 terms. Well, the only thing is m squared. So to rewrite this, we're left with 3m. Now be careful, a lot of you probably put just 3m, right? Because we took an m squared out. But if we do m squared times 3m, will that give me my 3m cubed minus m squared? No. So you need to have a minus 1. Because remember, anything you multiply by 1 gives itself back. Okay, so be careful on that. Now let's look at the next one, 9m minus 3. Well, they have a number in common. And notice we have a plus sign, so I bring it down. So I'm left with 3m minus 1. Always multiply those numbers back just to make sure, am I getting my problem back, okay? So now we put things together. We put the m squared and plus 3 together. Okay? And notice that my factors are exactly the same. So if they are not the same, you need to rethink your work there. Okay? So my 3m, same factor. So I'm going to have 3m minus 1. Okay? Now let's see if we can factor any more. Well, m squared plus 3. Now this is not a difference of squares because 1, we are not subtracting, and 3 is not a perfect square. And 3m minus 1, well, that is just a linear expression, so we can't factor that anymore. So this is our answer. Now, before we go into our second part of the video for these notes, I do want to talk about what happens if we had, instead of a plus, a minus sign when we do factor by grouping, okay? Well, if that is the case, and I'm just going to take this, which probably will not work out, but that's okay. Actually, I can change this. So let me just rewrite this. So I have 3m cubed. So you might want to add this to your notes. Because I have 3m cubed plus m squared minus 9m. I think that will still be minus 3. Okay. So notice here for this problem, I have now a subtraction sign instead of addition from the 9m. Now we factor like usual, so we have this. And then, now for when you have subtraction, include that, okay? Include it inside the parentheses. Because it is going to be important to take that negative out. So the first one we take just an m squared out. And we're left with 3m plus 1, okay? The next part, you're going to take a negative 3 out. So anytime you have subtraction, put that as part of the parentheses and then take it out. And so now we're left with 3m, and this is where you got to be careful because it's not going to be minus 1, but it's going to be plus 1, so that when we do negative 3 times positive 1, that still gives us our negative 3. Okay, so just be very careful whenever there is a subtraction sign in front and you're a factor by grouping. Put it as part of that second grouping part and then take it out when you are factoring. Okay, make sure you watch the next part of our 5.4 day